Hey guys, welcome to this tutorial on creating a touchscreen slider. So this tutorial will be using a system that I had set up in one of my earlier tutorials, which you can view over here. But yeah, all the scripts will be provided in the starting file in the description, so you don't have to watch that if you don't want to. So over here in Unity, I have a very simple scene set up. It's basically a light source, the main camera, and it's got the touch input script attached. You're welcome to download this starting file from the description if you wish. And to start things off, let's just create a simple slider graphic. So we can just make this out of our basic shapes. We can just add in a cube, which can be the sort of knob of the slider, and a quad, which we can scale out and down a little bit on the y-axis just to sort of be the bar of the slider. So let's name that bar, and I'm going to give this a sort of grayish color. Yeah, so the actual appearance of the slider is really not the focus of this tutorial, so just going to leave it at that. And I want to create an empty game object, and we can just call this the slider and parent the bar and knob to it. So now we can easily move this whole element around. And to the slider we want to add a box collider, and we can just resize this to sort of fit around the bar. And this box collider sort of defines the area in which the slider can actually receive input. So now let's go into our scripts folder and just create a new C# script called slider, and we can attach that to the slider object and open it up. And let me zoom in a little bit. One of the most frequent complaints on my tutorials is that the text is too small, so there you go. Let's create a public transform knob, just so we can move that knob around, and I'm going to delete this annoying default comments. Now to receive input on this slider, we need to have a void on touch stay, and we can add a vector3 point so that we know the position of the user's finger or stylus on the screen. And you can see this method is being called from the touch input class. It's being called over here. And basically we just want to have a private vector3, which is going to be our target position, and in the start method we want to set the target position to the knob's initial position, so just knob.position. And so in this onTouchStay method we just want to set the target position equal to the input position, this point vector, but only along the x-axis, because of course we don't want our knob sort of jumping up and down along the y-axis. So we'll create a new vector3 and just get the point.x, and for the y and z values we can just use targetpos.y and .z, so it just stays where it was initially on those two axes. And in the update method we basically just want to smoothly move the knob from its current position to the target position. So we can do that easily by saying knob.position is equal to vector3.lerp, and as you most probably know, lerp takes in an initial position, an end position, and a sort of a percentage between 0 and 1 between those two values. So for our starting position we get the knob's position. For our end position, that's of course our target position, and we want to just continually moving towards the target position, so we can just have time.delta time multiplied by some value like 7. And now if we run this, this should actually be working fairly well already. Let's just assign the knob transform to our little box over there in the inspector. And yeah, it's sliding along quite successfully. So we'll get into a few refinements in a moment, but let's actually make this functioning. So what we want is basically a value called the slider percent, which will go from 0 to 1. 0 of course being when the knob is on the far left, and 1 when it's on the far right. So we can calculate this fairly easily. Let's create a private float slider percent for this, and we need to know the length of our slider in order to calculate it. So we can have a private float slider length, and the length, well, that's quite simply the x size of the box collider. So we can get the box collider component just by saying get component box collider dot size dot x, and we're just sort of assuming that this object has a box collider attached to it, and if it doesn't, this will return an error. So it's always just good practice to make sure that this any object that the script is attached to does indeed have a box collider, and we can make sure of that by adding this require component statement in here. We can say require component type of box collider, and with this line we're just saying that whenever we add the script to an object, automatically add a box collider and don't let the user delete it because we need it. Anyway, we've got the slider length, and now with that we can calculate the percentage. So we can say slider percent is equal to, and now we need to think about this. So basically how we're going to do it is the local x position of our knob at 0 is in the exact center of the bar. So to get the position right at the end, we need to add half the bar length, and then if we just divide it by the bar length, we'll then get its percentage from 0 to 1 along the bar. So let's code that. Slider percent is equal to knob dot local position dot x plus the slider length. For some reason it thinks it doesn't exist, plus slider length over 2, and then divide all of that by the slider length. Okay, and let's create a bit of text to go under the slider so that we can show the user exactly what value the slider currently has. So we'll create a reference to this text, which we'll create in a moment. Public text mesh. We can call this just call it text mesh. I don't really have a good name for it at the moment. And let's also create a public string for the name of the slider. So we can call this slider name. All right. So now let's go back into Unity and just create a 3D text object. Just wait a moment, Unity's being a little bit slow for some reason. There we go. And I have a simple font which I'm just going to drag onto it. And you can see by default the quality of the text is absolutely awful. The way we can increase the quality is just by increasing the font size over here. And then we can just scale down the character size. And we've got a much crisper text now. We set this to maybe middle left, and I'll just put it over here. I still want this a little bit smaller, actually. And this is going to be my volume slider. So just to test out how it will look. Yeah, something like that. And we can call this our value text, or whatever you want to name it, and just put it under the slider parent and apply it. And for our slider name, well, it's our volume slider, so just call it volume. And now back in the script, let's display the slider percent by saying text mesh.text is equal to the slider name. And now let's add a little colon to the end of that. So plus a colon and add a space plus the slider percent. Okay, now we can see if that is working. Okay, so here it's equal to 0.5, and yeah, it's working very nicely. One thing you can notice is because of this smoothing, we actually struggle to reach 0 and 1 on either side. And so one thing that's actually quite nice to do is when we're setting the slider length, just subtract some small value from this. So maybe 0.4. And then it just gives us a sort of bit of leeway on the start and end. And you can in fact see here that it's going into negative numbers and past 1. So we want to clamp it within that range of 0 and 1. So if we just go into the script and go over to where we're setting the slider percent, we can just add mathf.clamp01 and just encapsulate this all in parentheses. So that clamps the value between 0 and 1, obviously. And now now you can see that it has this little range over here where it will be equal to 1, and this little range at the end that's equal to 0. Just a sort of little buffer area. So what's next? Let's get some way for another script to actually get this slider percent value so that it can be used in some meaningful way. So we can create a method, a public float, get slider percent, and this will return the slider percent, obviously. Okay, so before we go any further with improving the slider, let's just create a script that will actually use the slider percentage so you can see how you actually apply the slider to work in your game or whatever it is you're making. So I'm going to create a new script, which I'm going to call my music manager, and I'm going to create an empty game object. This will be my music game object, and so of course it will have an audio source component. And I've got this little track that my friend played the other day on my keyboard when he was here, and you can just set this to loop and apply the music manager script to this music. What's going on? To the music empty. And if we open this up, we can basically just have a reference to the slider, so public slider, and we can call it volume slider. And in the update method, we can just say audio.volume is equal to volume slider dot get slider percent. Simple as that. It's now integrated into our game. So just to demo this, let me drag my slider in here and press play. Okay, so it works as expected, and now let's just add a few refinements to the slider. Basically, this value over here, first of all, we don't want all those ugly decimals. We want to be able to define how many decimal places we want it to display, and also we want to be able to give it a custom range. So internally, we'll always use the values 0 to 1 for working with our slider, just because they're very logical values. But in your game, you might want it from 1 to 10 or from 1 to 100 or anything. So in the slider class, let's create a public int array for our value range, and we can also create a public int decimal places, and so we want the text to be set to the not a slider percent, but rather a slider display value, we can call it. So let's create that, a private float slider display value. And so we quite simply want to set slider display value equal to somewhere between the minimum and maximum value range that we've defined. So we can just use mathf.lerp. So from will be value range 0, so the first sort of index, and value range 1, the second index. And for our percentage, well, we've got our slider percent for that. And now to display it to the correct number of decimal places, we can, first of all, let's change this to slider display value. And now we can just say dot to string. And here we can pass in our format, and the format basically goes like this. F plus the number of decimal places you want, so 2, 3, 4, etc. So you can just say F plus decimal places. So let's go into Unity and set those values we've just created. So we've got a value range. We want the size of the array to be 2, a minimum and a maximum. So we can start from 0 and maybe let's end at 10 and set the decimal places to 2. So now, let me actually just go onto the music thingy and maybe just disable play on awake. And now, you can see it's at 5, and it goes up to 10 and 0, and it's displaying to 2 decimal places. And you can see we can change if this is 1 decimal place, 5 decimal places. We can end it at 100, and for whatever reason start at -5. -5, 100. So it's very customizable. So the last thing that we maybe want to do is to be able to set a custom starting point for the slider. So maybe by default you want your volume to be 0.75 or 0.25 as the sort of recommended level or whatever. So in our slider script, let's create one last public float. We can call this the initial slider percent. And in the start method, we'll just set the slider percent straight away equal to the initial slider percent. And here where we're setting the target position, to the knob position, we'll now add vector3 dot left. Oh, actually, let's make this vector3 dot right. So vector3 dot right is just a vector with a value of 1 on the x-axis. So from the knob position, which remember is the center of the bar, we want to first of all move it all the way over to the left, just as a sort of starting point. So we add vector3 dot right multiplied by the slider length divided by -2. So that this value here is now the far left of the slider. And now we just want to add slider length multiplied by slider percent. So when slider percent is 1, for example, so it should be on the far right, we're adding slider length times 1, so that of course moves it all the way from the far left to the far right. And we can just straight away now set the knob position, knob.position equal to the target position. So now we can set an initial slider percent, say 0.25. And there we go, it's at 0.25. Anyway, that's all the basic functionality we really need for this little slider. I hope you've found this tutorial to be useful. And if you have any questions, feedback, whatever, just leave a comment or send me a message on Twitter. Cheers.